Okay, for question 2, probably the easiest way to approach this would be to first of all think about the original function and make a table of values, because if we're on the domain 0 to 5, that's 0, 1, 2, 3, 4, 5, so it's not too much work to just pop those into the original equation if you set them in for x, and then we would get 3, it looks like it's going to go up 6, oh no, it's quadratic, sorry, it's going to be 2 squared is 4, plus 4 is 8, and then 3 is 9, plus 6 is 15, 16 plus 8 is 24, and then for 5 we would get 35. So what happens with an inverse is that x and y just kind of reverse places. They just kind of trade places. So what we're looking for in our inverse ordered pairs is anything that matches with the opposite of what we see in our table of values. So for instance, I've got 1, 3, and so 3, 1 would be the inverse because the y and the x have traded places. There's no other point where I've got a point in the opposite order, like 0, 2 I don't have in my chart, and 2, 4 I don't have in my chart. So that's why 3, 1 is the only point that would meet that criteria. All right, for problem 3, I'm going to try to squeeze a few of these in just on the same page so we have the same question in front. Easiest way to find slope is y2 minus y1 over x2 minus x1. And so what we're going to do is just take our two y values and subtract them on top, and take our two x values and subtract them on the bottom. So we end up with 6 over 4 or 3 over 2, and that's our slope. Okay, another way to write y2 minus y1 over x2 minus x1 is delta y over delta x, or rise over run might seem familiar from the past classes that you, oh, did I write rum? Must be getting late in the day. Rise over run. All right, problem 4. Find a number k such that the line containing the points 2k and 5, 8 has a slope of 2. So let's go back to the previous formula that we used here. And let's just, I'm going to change colors a little bit so we can keep them straight. Let's just set this up as if we're trying to find the slope and didn't realize that we were missing one of the values. So if I put in 8 minus k for my two y values, and then I put in 5 minus 2 for my two x values. So on the bottom, 5 minus 2 is 3, and 8 minus k is still there on top, and that's where I have to use a little bit of logic because it has to come out to 2. So the only way it's going to come out to 2 is if the top is equal to 6, right? So 8 minus k would have to be 6, so that 6 divided by 3 is 2. And so in that case, we want k to be 2 so that that happens. For problem 5, the equation of the line, let's try and squeeze this one in also, just so we don't have to keep going back and forth on our pages. First thing we need is our slope, and so y2 minus y1 over x2, sorry, that's 4, minus x1. So I'm going to get 4 over 3 for my slope. And we know that y equals mx plus b, but the other equation that you gave me was y2 minus y1 equals m times x2 minus x1, right? And you're saying you're not sure when to use which equation. The answer is it doesn't matter, because if I start with y equals mx plus b, because we're all used to working with that one in school, then I can just throw my y and my x value in there. I'm just going to choose the easiest of the 2 points, the 1, 3. So when y is 3, x is 1. And because everybody and his dog has a fractions calculator now, you know, with the A, B, C on it, then you can easily put that into the calculator. B is just going to be 3 minus 4/3 here, because we have to take the 4/3 over to the other side and subtract, and your ABC button will do that for you, and it will tell you that your answer is 5/3. And so we can write our equation as y equals 4/3 x plus 5/3. the other way that you would get the equation if you did that other formula would be 3y equals 4x plus 5, and they're both the same equation, so you don't have to worry about which one to use. Just use the one you're most comfortable with. Okay, so problem 6, I'm just going to go to another page because we're getting kind of crowded here. Hang on a sec. What are we going to? 9. Okay, so problem 6. Hang on. For question 1, we've got the g inverse of y, which means that if I was, I'm just going to choose a different example for an equation for a minute, just over to the side here. If I had something like y equals 2x plus 6, then the inverse of that is when we switch out x and y for each other, like that, okay? So really what you're looking at there is you're looking at x equals 3y minus 2. And so if x is 7, because that's what g of x is, then we're going to go 7 equals 3y minus 2. And then if I bring that 2 over to the other side, I'm going to add it, and that makes 9. So I have 9 equals 3y, and then y equals 9 divided by 3, and that's equal to 3. And so that's what they mean by the inverse of a function, and that's how you would solve a question like that. All right, I just wrote it on another page so we'd have more room to work here. Okay, so this one's going to start off the same as number 5. We've got 2 ordered pairs given, which means we can find the slope. 7 minus 3 over 6 minus 2. Slope is 4 over 4, which is 1. That's a nice number to work with. And then we can do y equals mx plus b, and 1 is the slope. And we can put in either one of our xy combos that we were given. So we'll choose the one with the lowest numbers to make the math easier. And it turns out that b must be equal to 1 here. So we have an equation, right? Y equals x plus 1. And if 4p has to be on that line, then this is our x value and this is our y value. So y is p, x is 4, and then b was plus 1. And so p must be equal to 5 if it's going to be on the same line. And that's all we have to do for that one. Okay, number 7 is just a little bit of a twist on number 6. We're going to do exactly the same thing, but because they stated that it has to be perpendicular to the line, then what we're going to do first is find the slope of the line that we're given. So we're going to do 6 minus 2 over 3 minus 1, and that's 4 over 2. So the slope is 2 this time. But before we go into the Q part of this problem, the slope of a perpendicular line is going to have a slope of minus 1 over 2. Because the rule is that you take a negative reciprocal. So if this is going to be 2 over 1, we need to make it negative, then we need to flip it to get the slope of a perpendicular line. That's what this looks like. It means it's just a short form for perpendicular. So we could do it this way. We could say, therefore, if we take those 2 points at the top, 5 minus 3 over 2 minus 2, we know that it has to come to negative 1 over 2, right? And so 5 minus 3 is 2, and then we have 2 minus 2 on the bottom, and it has to equal negative 1 over 2. So one way to handle this would be to cross multiply. It's going to be the same idea, but now they're saying parallel. And parallel lines, we use a little symbol like this, have the same slope. Okay. And so if we find the slope of the line that we were given, studied a pointed intersection of two straight lines using either substitution or elimination. In this case, if we look at what we have here, it says y equals 3x plus 2. It also says that y equals negative x plus 4. So if they're both equal to y, then they have to both be equal to each other. So what we're going to do is just grab the right-hand side of both of these equations. The left-hand sides are equal anyway. And we're just going to solve this as a linear equation. So we bring the x over to this side and add it. And then we bring the 2 over to this side and subtract it. And I'll let you finish that one off as well. And you'll just get your x value. And then what you're going to do is when you have your x value, you're going to sub x into one of the equations. I would recommend equation 1 because there's no negatives in it. And that's it. Okay? Hopefully that helps.